trouble with those rational functions, huh?
Well, today's your lucky day because today's lesson is going to be on rational functions.
Welcome to James Academy. Today we're going to be talking about rational functions.
Hi, my name is Professor Samantha, and in this video I'll be teaching you the knowledge question of solving rational functions. So here we are asked to solve for the value of r, so we're supposed to solve the rational function. And that means that we're trying to find all the possible values of r. So the first thing you want to do when you're usually solving for the rational function is to bring everything to one side and set the other side equal to 0. But here you have a special case because the denominator on the right side is both r minus 2. So that tells us right away that we can simply simplify it. So I'm just going to simplify it right now. So r plus 4 plus 6 over r minus 2 is equal to 1 over r plus 3. And when you simplify that, you get r plus 10 over r minus 2 is equal to 1 over r plus 3. And now you just bring everything to one side and set the other side equal to 0. So I'm going to set the left side equal to 0 and bring the 1 over r plus 3 to the right side. So 1 minus r plus 3. And here you just use the common denominator rule where you subtract fraction. So r plus 10 multiplied by r plus 3 over r minus 2 r plus 3 minus 1 times r minus 2. So when you simplify that, you get r squared plus 13r plus 30 minus r minus 2 over r minus 2 r plus 3, sorry. So, and then it's basically simplifying it all down. R squared plus 13r plus 30 minus r plus 2 over r minus 2 r plus 3. And then once again simplify the numerator, so the 13r and the negative 1r, so it becomes r squared plus 12r and then plus 32 over r minus 2 r plus 3. And now you can just bring this side over, and when you bring both of them to the other side, it becomes multiplication, but 0 times anything is 0, so it's 0 equals r squared plus 12r plus 32 is equal to 0. And then this, you can see, is a basic quadratic equation, and you can just use a factoring rule. You can use a quadratic formula, but this one is pretty easy, so I'll go ahead and solve it right away. So 8 times 4 is 32, and since the 12 is positive, I'm going to assume that they're both positive. So r plus 8 times r plus 4 is equal to 0. And as you can see, these are the values of the r, but you have to remember that once it comes out of the bracket, it's negative 8, or it could be equal to negative 8 or negative 4. And that is how you solve an equation. Thank you for watching.
Hi, my name is Professor Hassan, and I'll be showing you the second application question. So this question is, the function pt equals 20t over t plus 1 models the population in thousands of Nickelford t years after 1997. The population of New Ironfield is modeled by qt equals 240 over t plus 8. Determine the years where the population of New Ironfield is greater than the population of Nickelford. The models are only valid for years after 1997, or t is greater than 0. So from this question, we can see the things that we're given. We're given the function of New Ironfield, qt equals 240 over t plus 8, and the population of Nickelford, pt equals 20t over t plus 1. We can also see that the year number is t plus 1997, since we know that t is 0. The question asks when the population of New Ironfield is greater than Nickelford. So the population of New Ironfield is greater than the population of Nickelford. So then we can bring this part over and make it 240 over t plus 8 minus 20t over t plus 1. Make this greater than 0 to make it easier for us to do the interval table, which will come later. And then after that, you find the common denominator, which is t plus 8 times t plus 1. And then to get the common denominator, you would do 240 times t plus 1 minus 20t times t plus 8. And remember to keep these greater than 0 so you don't lose marks. And then after that, you expand it. So 240t plus 240 minus 20t squared minus 160t over t plus 8 plus times t plus 1. After that, you simplify it just to make it a bit easier. And then you factor out the minus 20 from the numerator, it's really important to make sure that you factor this out. And then after that, you factor what's in the brackets in the numerator. So you get minus 20 times t minus 6 times t plus 2 over t plus 8 times t plus 1. Now we have to find two more important pieces of information, which are the vertical asymptotes and the x-intercepts. The vertical asymptote is the number that makes the brackets in the denominator equal 0. So minus 8 plus 8 is equal to 0, and minus 1 plus 1 is equal to 0. So those are the two vertical asymptote values. For the x-intercept, those are the values that make the numbers in the bracket equal 0. So 6 minus 6 equals 0, and minus 2 plus 2 equals 0. Once you have these two pieces of information, it's good to just sort them out from lowest to highest. So minus 8, minus 2, minus 1, and 6. So now off to the harder part, the interval table. So what we do is the first column should be the function, the simplified function, which is minus t times t minus 6 times t plus 2 over t plus 1 times t plus 8. And now how this works is we find the values that are less than the lowest number, each values that are between the numbers, and then the value that's greater than the highest number. So we will start by doing t minus 8 for t when t is less than minus 8. So then what you would do is you would find any number that's in that range. So we could pick minus 9 for example. And then you just need to find the coefficients of it, if it's a positive or a negative. So since minus 20 is negative, you will start with minus 20. And if you pick minus 9 minus 6 is a negative number, so that'd be another number. Minus 9 plus 2 would also be a negative number, so you put negative over there. Minus 9 plus 1 and minus 9 plus 8 are also negative numbers, so two negatives in the bottom. Everything added together, all of the signs when added together would also make a negative. So you would put negative there. The next step is the numbers that are between that number and the next number. So when minus 8 is less than, when t is less than, the next part would be to find when t is greater than minus 8 and when it's less than negative 2. So we can pick a number like negative 3. You would basically do the same thing as the last one, where you only find the numbers, where you just plug it in where you plug a number as t. And then solve to find if it's a positive integer or a negative integer. So you'd solve all that, and then once you do that, you would get a positive number. You would do the same thing for all the other ranges. When t is greater than minus 2 and less than negative 1, when it's greater than minus 1 and less than 6, and when it's greater than 6. So yeah, you would just do all that, and then find if it's the whole thing is a positive or a negative integer. And yeah. Now the question asks when it's greater than the other city. So we would find the numbers that are positive since it's greater than 0. So we can see that the two intervals where it's greater is minus 8 when t is greater than minus 8 and less than negative 2, and when t is greater than minus 1 and less than 6. But the question asks the model is only valid for t years when t is greater than 0. So we can see that this one is greater than minus 8 and less than minus 2 is a positive, but the two values are less than 0. So we can't use that one. However, we can use minus 1 is less than t when t is greater than minus 1 and less than 6. Since for the majority the numbers are greater than 0. So we would find it. We can also say t is 0, so it would be 1997 to 6 plus 1997 since the 6 is here. And then you would just solve for it using the other formula. So 1997 to 2003. So therefore, the population near Ironfield is greater than the population in Nickelford between 1997 and 2003.
Hey there, my name is Mr. Kurnavat and I'll be doing the application portion of rational functions. Alright, so let's get started. Here we have an application question that says, when astronauts go in space, they feel lighter. And this is because weight decreases as a person rises above Earth's gravitational pull. And here we are given a formula, an equation, to find the astronaut's weight in space with respect to the astronaut's weight on Earth and how the height of the astronaut above sea level. Alright, so here we have our first question, and it states, what is the astronaut's weight at each altitude? If the astronaut's weight is originally 820 newtons on Earth. The first height is 10 kilometers, so now the first thing you would do is actually look at the initial formula. Over here we have three variables, the astronaut's weight at each altitude, the astronaut's original weight, and the height above sea level. Over here, in the question, we're given the astronaut's original weight of 820 newtons and the height above sea level. So, what's the first thing we would do? Plug those values into the formula. So, initially, let's write down the formula first. Which is that? WE over 1 plus h over 6,400 all squared. Now, we will plug in the values that we know. So we're trying to find astronaut's astronaut's weight, and we know that his original weight is 820 newtons, so we plug that in, all over 1 plus the height of 10 kilometers over 6,400 all squared. So what's the next thing you do? You solve the denominator, because if you look at it, we're trying to find the weight of the astronaut, and over here the 820 is ready to go, but the denominator is kind of complex, so we're trying to solve it out. So now you would just do I'll just solve the right side over here, 820 or 1 plus, now just plug that into a calculator. I mean, that's what I would do. So just basically 10 divided by 6,400 equals to 0.001, as you can see, and just add 1 to it, and so you get 1.001 all squared, and then when you square that answer, you get 1.003. So now it would be 820 divided by 1.003. And now plug that into a calculator. 820 divided by 1.003 will give you 817.44 newtons. Sorry about that. Well, that's the weight of the astronaut at 10 kilometers of altitude. Alright, so here we have the second question. And the second question states that find the altitude when the astronaut's weight is 10 newtons above sea level. So the first thing you would want to do to solve this question is write down the equation that we are given, which I already did over here. Now what you want to do is plug in all the information that you're given. So we know the astronaut's weight is 10 newtons above sea level, so we plug that in for WH. And we also know that the astronaut's original weight is 820 newtons, so we'll plug that in for WE. All over 1 plus h over 6,400 all squared. Alright, so now what you want to do is actually get rid of that square. And to do that, I'll just square root everything, the whole equation. So it's just going to be root 10 equals to root 820. Yes, you do root the numerator, all over 1 plus h 6,400. Oh, sorry, it's not root. We just got rid of that, so that won't be there anymore. There you go. Now that's what we have. And now what you want to do is actually bring the denominator to the other side. Just get rid of that denominator from one side. So what I would do is multiply here by 1 plus h over 6,400. So we just got rid of that, but now we also got to multiply it up here So it would be root 10 times 1 plus h 6,400 equals to root 820. Now what you want to do is actually expand this bracket. So now it would be root 10 plus root 10h over 6,400 equals to root 820. Now we have that ready to go. Now you want to actually add up the left side. To do that, you gotta make the denominator same. So it would be 6,400 root 10 plus root 10 h all over 6,400 equals to root 820. Now, since we have all this set up, you want to bring the denominator, you want to get rid of that denominator from the left side. And to do that, I'll just multiply the right side by 6,400 and the left side by 6,400. And so now it would be, it would just be 6,400 root 10 plus root 10h equals to 6,400 times root 820. Alright, so now let's just write up here a big arrow. Woo! Here we go. Okay. So this is where we're left at, and now what you want to do is isolate that h and root 10 on the one side because we're trying to find the height, right? So what you would do is h root 10 equals to 6,400 root 820. Over here it's a positive, so you would just subtract 6,400 root 10. And now you just plug these values into a calculator, and so it would be h root 10 equals to, I just plug it into a calculator. I would just do the whole thing at the same time, so 820 equals to 183,268.11. We're gonna round it up to 10 decimal place. So you have 1,803,268.11 minus 6,400 times root 10, which is 20,238.58. Ooh, barely made it. Okay, so now you just subtract these two values together, so it would be h root 10 equals to the first one, which was 183,268, oops, 0.11 minus 20,238.58, which is that 0.53. And now to find h, what is, take 163,029.53 and divide it all by root 10. So I have it right here, and I'll just divide it by root 10. Boom. And that's the height. 51554.46 kilometers. So the astronaut's weight is going to be 10 newtons above sea level when the astronaut is 51,554.46 kilometers from Earth. Thank you.
And today we'll be discussing the question, when does a function have a hole? And we'll also be giving examples. A function has a hole when a factor completely cancels out the denominator. Note, the whole denominator does not have to cancel, just the factor. For example, the function fx equals x plus 1 multiplied by x minus 2 over x plus 1 multiplied by x plus 5 has a hole at x equals -1. This is because it cancels out the denominator, leaving us with just x minus 2 over x plus 5. If a factor does not fully cancel out the denominator, then the function has a vertical asymptote. For example, fx equals to x plus 1 multiplied by x minus 2 over x plus 1 squared multiplied by x plus 5. This cancels these out, but leaves us with an x plus 1 on the bottom, which then turns into an asymptote, a vertical asymptote, along with x minus 5.
Alright, now onto the paper. This is where I'll be showing you how to graph a graph with a hole. We're going to be using this equation right here, fx equals to x plus 1 multiplied by x minus 2 over x plus 1 multiplied by x plus 5. The first thing we do is we get rid of the factor, x plus 1, leaving us with x minus 2 over x plus 5. Now that we know that at x negative 1 there's going to be a hole, we can find the y value by basically subbing in that negative 1 into this new leftover equation, giving us basically a hole at negative 1 and a negative 0.75. We then find the vertical asymptote, and the way we do this is we basically make the denominator equal to 0, and we bring over the 5, which leaves us with negative 5. Horizontal asymptote is found by, in this case, dividing the numerator by the denominator because they have the same degree, which will leave us with a horizontal asymptote at 1. The x-intercept is found by making this whole equation equal to 0, and then bringing over the 5 and getting rid of it completely, leaving us with x minus 2. Bring over the 2, which would leave us with an x-intercept at 2. The y-intercept is found by subbing in x to be 0, and it would leave us with 0 minus 2 over 0 plus 5, which would mean that we're dividing the negative 2 by 5, giving us negative 0.4. It is very essential to find the behaviors when graphing. And the way we do that is we basically add a value or subtract a value such as negative 1 and add a value such as negative 1 or 0.1, sorry. And that would mean that we would sub this new x value into the equation x minus 2 over x plus 5, which would give us a y value that's positive for this and negative for this. And that would mean that as x approaches negative 5 from the left, y would be going up to infinity. And as it approaches from the right, it will be going down to negative infinity. And here we can see that to find the horizontal asymptote, or the end behavior of that, we would sub in a high value such as 100 and a low value such as negative 100. And we would just sub it into this equation. And after we do all the calculation, we would see that we would get 0.93 and 1.074 as the y values. Since this one is smaller than 1, it will be below the horizontal asymptote, and this one is higher. That means it will be above. Now onto the graph. The way we did the graph is basically we plotted the x-intercept at 2 and the y-intercept at negative 0.4. We also then drew the y equals 1 horizontal asymptote and x equals to negative 5 as the vertical asymptote. And as you can see, there's also a hole right here at point negative 1, negative 0.75. You can also see that as it approaches to negative 5 from the left, it rises, and as it approaches from the right, it basically drops. And for the horizontal asymptote, as it goes to a positive 100, it would be below the 1, and as it approaches negative 100, it will be above. And that's how you basically graph a graph with a hole. Thank you.
My name is Professor Khan. Today I'll be doing the thinking question for rational functions. So the question here is, create a rational function in standard form, which has a hole at x equals negative 5 and at x equals 2. It has x-intercepts at x equals negative 3 and x equals 4. It has a y-intercept at y equals 4, an oblique asymptote at y equals x, and a vertical asymptote at x equals 1. So first of all, we're going to write what we have. We know that we have a hole at x equals negative 5 and x equals 2. We also know that we have an x-intercept at x equals negative 3 and at x equals 4. We know we have a y-intercept at y equals 4. we also know that we have an oblique asymptote at y is equal to x. And finally, we know that we have a vertical asymptote at x equals 1. So first of all, we're going to use the hole in the equation. To get the hole, we do y is equal to x plus 5 times x minus 2 over x plus 5 times x minus 2. Because we know that for the whole, the numerator and denominator will cancel out, and it will create a special case in the equation. So the whole is done. Now for the x-intercepts, we know that we have an x-intercept when y is equal to 0. So now in that same equation, we're going to rewrite that, and add x plus 3 and x minus 4, since we know that the x-intercepts are at negative 3 and at 4, and we need to make them equal to 0. So negative 3 plus 3 is equal to 0, and 4 minus 4 is equal to 0. And we write this part again, the denominator. So now we have our x-intercepts done as well. For the vertical asymptote, we know that we have to make the denominator equal to 0, because we need to make a case in which the denominator will equal to 0. So now we're going to write this exact same equation again. Minus 2x plus 3x minus 4 over x plus 5 x minus 2. And now we know that the vertical asymptote is at x equals 1. So we're going to make this in the denominator x minus 1. Since we know 1 minus 1 is equal to 0, and that in the denominator we will now get a 0. So vertical asymptote, we're done. Now for the y-intercept, we know we have a y-intercept when x will equal to 0. Therefore, we will sub in 0 for each of the x's. So we will have 0 plus 5, 0 minus 2, 0 plus 3, and 0 minus 4, all over 0 plus 5, 0 minus 2, and 0 minus 1. So we subbed in 0 for all the x values. However, we know that the y-intercept is equal to 4. So we need to make all of this equal to 4. So once we sub in 0 for each of the x values, now we can figure out what the y-intercept is. So we will do all of these numbers in the numerator multiplied by each other over the numbers in the denominator multiplied by each other, which will give us a final answer of 12. However, we know that the y-intercept is equal to 4. So we will divide this by 3, and it gives us an answer of 4. So to get that answer of 4, we simply just had a 3 in the denominator. So now, our equation so far is going to be this equation right here. It's going to be y is equal to x plus 5, x minus 2, x plus 3, x minus 4 over x plus 5, x minus 2, x minus 1, and that multiplied by 3. So now we have our equation so far. So finally, for the oblique asymptote, we have to divide the numerator by the denominator. And once we do this using synthetic division, we get an answer of y is equal to x. I didn't really use synthetic division because it's going to be too much work. But we get y is equal to x, and that is our oblique asymptote. Finally, we have to expand this entire equation. So once we expand it out, we get y is equal to x to the 4 plus 2x cubed, subtract 12x squared, minus plus 3x cubed, minus 3x squared, minus 36x minus 10x squared plus 10x plus 120, all over 3x cubed minus 3x squared plus 9x squared minus 9x minus 30x plus 30. And now we can finally simplify this big, enormous equation and get down to y is equal to x to the 4 plus 5x cubed minus 25x squared minus 26x plus 120 all over 3x cubed plus 6x squared minus 39x plus 30. And finally, we have our final equation, and we're done.